Radiometric dating anomalies. What are radiometric dating anomalies? How about I click on my slides again so that I can make them advance. So there are many examples where the dating methods give dates that are wrong for rocks of known historical age. Anybody recognize that picture?
Is that Mount St. Helen?
That is Mount St. Helen. So the younger people don't recognize it because that volcano erupted during Steve and my lifetime, so we know about it. People died from that eruption. So we know when the rocks in the core of that volcano were created. So an example is a, boy, I don't know how to pronounce that, dacite lava dome. I guess I'm gonna have to look it up. I usually do look up everything to make sure I'm very clear on what I'm talking about. At Mount St. Helens volcano. Although we know that the rock was formed in 1986, the rock was dated by the potassium argon method, which is typical for lava flows. That's what you use. Potassium argon, and the method said that it was 0.35 plus or minus 0.05 million years old, right? Way, way off, way, way off. Another example is potassium argon dating of 5 andesite lava flows from Mount, there's a tough one, Ungaruho in New Zealand. The dates ranged from less than 0.27 to 3.5 million years. But one lava flow occurred in 1949, 3 in 1954, and 1 in 1975. Now, these are only a couple of examples. Actually, I could spend the rest of the talk talking about all of the examples of this kind of mistake of dating known rocks, and yet it gives far too old of an age. So what happened is that excess radiogenic argon from the magma, the molten rock, so that's potassium, radioactive potassium decaying into argon from the magma was retained in the rock when it solidified. Now that's not supposed to happen. And the reason is the argon isn't supposed to be there in the magma, right? Because the magma is supposed to be billions of years old. So the argon, which again is a noble gas, it does not form chemical bonds. So it would migrate out of the magma easily and out to the surface of the earth, and especially during volcanoes, it would just off gas immediately. So the excess argon appears to have come from the upper mantle below the Earth's crust. This is consistent with a young world, right? Because in a young world, remember, there hasn't been any time for the argon to off gas, just as we know there hasn't been enough time for helium to off gas from the rocks. Right, all of this helium and this argon that was created by radiometric decay that happened right at creation. Millions of years worth of radiometric decay occurring at creation. So excess argon can cause exaggerated dates for rocks of known age. Then why would we trust the method for rocks of unknown age, right? Things get harder to date the further back in time you go. Even if the difference is only a few thousand years, it still increases the margin of error. Conflicting dates between different methods. So what happens if you use different methods to try to get an answer? Well, if two methods disagree, then at least one of them must be wrong, right? And this happens all the time. What geologists will do many times is they think they have a theory that a certain rock layer or geologic feature is of a certain age, based, on their own theories, and so they will have it tested. If one method doesn't give them the date that they think it ought to be, they will just use a different method, because they know full well that these different methods give different ages for the same rocks. So, for example, in addition to that, you can have different artifacts that are found, right? So in Australia, some wood was buried in a basalt lava flow, right? It can be seen from the charring that the wood was actually charred by the heat of the lava. So there's no doubt that it was there at the time that the lava flowed, right? The wood is dated by radiocarbon analysis at 45,000 years old, but the basalt is dated by potassium argon at 45 million years old, right? Completely diverging. And again, this is not the kind of thing that should be happening if the Earth is old, but it is exactly what we would expect to happen if the Earth is young. Again, retained argon, right? And we'll get into a little bit about carbon dating and why it says 45,000 years old instead of, say, 4,500. Other fossil wood from upper Permian rock layers have been found with carbon-14 still present. Detectable carbon-14 would have all disintegrated if the wood were older than 50,000 years, let alone the 250 million years that the evolutionists assigned to these upper Permian rock layers. Okay, carbon-14 dating. Let's jump into that quickly. So carbon-14 has a short half-life. It's about 5,000 years. So half of it is gone in 5,000 years. And then in another 5,000 years, the other half is gone. Or not the other half, but half of what is remaining is gone. So that any sample older than about 60,000 years, the earlier slide said 50,000, it's, depends on how sensitive the equipment is, and now they're down to being able to measure every single molecule of carbon-14, or every single atom, I should say. So 60,000 years should have no carbon-14 left at all. So therefore, until a few decades ago, no one ever bothered to date fossil carbon sources like coal or dinosaur bones or anything, right? Anything that they found that was, say, 100,000 years old or older, they would just not bother because it had to be zero. But we now know that coal, oil, fossil wood, and even diamonds have carbon-14 dates in thousands of years and not millions, right? Even diamonds, so that the argument, well, it's somehow being contaminated, which, by the way, the people who do these tests say that's not possible. They're very, very good at what they do. They make sure that their samples have not been contaminated. And again, they can measure every single molecule, every single atom. So it's not like something is getting in that they don't know about. In 2012, 10 different samples from 8 different dinosaur bones gave dates in thousands of years, not millions of years.